Okay, business and algebra, no one sent me any specific questions about the test 3 review, so I'm picking them myself. I'm going to start with 2 from the system of equations style problems, starting with number 6 on the test 3 review. It says negative x minus 4z equals 3, 4x plus 3y plus 2z is 11, 5x minus 3y plus 2z is negative 18. So normally I talk about you get to choose which variable you eliminate, which is still true. But if you have an equation like this, which is already missing one variable, it's really trying to make you do less work than you're currently having to do. For example, you already have an equation with y eliminated. Since you only need 2 equations with x and z, you already have one with x and z. Your goal needs to be get a second equation with just x and z. Which means if I can find a way to cancel out y and between the other 2 equations, that's what I should go for, and then I'm just down to 2 equations and 2 variables. Even more lucky on this problem is for these 2 equations, we already have a perfect alignment to get rid of the y's, positive 3y and negative 3y. So if I add equations 2 and 3 together, I get 9x, my y's cancel, 2z plus 2z is 4z, and 11 minus 18 is negative 7. So I get 9x plus 4z is negative 7. I can then use that to combine with my first equation to eliminate another variable. And conveniently, it's already lined up to where z is going to cancel just by adding this 4th equation with my original first equation from the top. So when I add those 2 together, 9x minus x is 8x. 4z minus 4z cancels. Negative 7 plus 3 is negative 4. So I have 8x equals negative 4. To solve for x, all I have to do is divide by 8. So x is negative 4/8, which can be reduced to negative 1/2. Okay, so now that I have one variable solved, x, I have an equation with just x and z, so I can plug in x to that to help me figure out what z is. So negative 1/2 minus 4z equals 3. Negative 1/2 becomes positive 1/2. So up here we have 1/2 minus 4z equals 3. Move the half to the other side. Now remember, 3 is 6 over 2, if we have a common denominator, minus this 1/2, because it has to be subtracted to get to the other side, is 5/2. So we have negative 4z equals 5/2. Divide by negative 4. Now remember, 5/2 divided by negative 4 is the same as 5/2 times negative 1/4. Multiply by the reciprocal. So then you multiply across. It's negative 5/8. So now I have z to go with my x. Both are fractions, but you'll live. Lastly, I need to find a y. So I can take either one of these 2 equations up here and plug in my x and my z to find my y. I'm going to take the one with all the pluses. It seems a little bit easier for most people to do addition. So 4x plus 3y plus 2z equals 11. That's equation number 2 from the beginning of the problem. Plug in negative 1/2 for x and negative 5/8 for z. So I get 4 times negative 1/2, which is negative 2, plus 3y. 2 times negative 5/8 would be negative 10/8, which reduces to negative 5/4. So it's negative 2 plus 3y minus 5/4 is equal to 11. Now, I can move the 2 to the other side. 3y minus 5/4 equals 13. Now, in order to move the 5/4 to the other side, I need a common denominator. 13 is 52/4. Add 5/4, you get 3y equals 57/4. And if you divide by 3, just like up here, it's multiplying by the reciprocal. You multiply the 3 into the denominator, so y is 57/12. That means my solution, because of course this is a system, needs to be like a 1 point, x, y, z. It's negative 1/2, 57/12, negative 5/8 is the solution to that system of equations. Now there's also some word problems on the systems of equations, like number 11. Where it says band concert tickets are $5 for adults, $3 for teens, and $2 for preteens. Now, it tells you that 570 people attended, and they spent $1,800 on tickets, And they give you this other piece of information, which is twice as many teens attended as preteens. Then how many of each group attended. So you need to turn that into equations. One equation is going to be the cost. Another equation is going to be the number of tickets. And the last equation is that extra statement, the relationship between the teens and the preteens. So the number of tickets sold, 570, is just going to add the number of adults, the number of teens, and the number of preteens together because they should all be buying one ticket. So I let adults be X, teens be Y, and preteens be Z. So X plus Y plus Z was 570. Now the cost is different for the different groups. The adults pay $5, the teens pay $3, and the preteens pay $2. Means 5 times the number of adults, plus 3 times the number of teens, plus 2 times the number of preteens, so 5x plus 3y plus 2z equals the amount of money spent on tickets, which we know to be $1,800. The last equation, because we need to have 3 variables, so we need 3 equations, says twice as many teens attended as preteens. That means y, the number of teens, is 2 times the number of preteens, which is z. So this is our extra relationship equation, y equals 2z. Now what I'm going to do is do this by elimination. This could be done by substitution using this, so if you do it that way, you can just substitute 2z into all of these and figure out what x and z are first and then come back to y. But if you're going to do it the way we did the problems above, I'm going to move the 2z to the other side by subtracting so that these all line up. Now by the same argument in number 6, this is already missing x. So if I can get rid of x between the other 2 equations, I'll have another equation with y and z. In order to do that though, between 1 and 2, one of them has a 5x, the other one has a regular x. I'd really like my 5x to line up with a negative 5x. So if I take negative 5 times the first equation, it becomes negative 5x minus 5y minus 5z equals negative 2,850. But this allows me to add it to equation 2. So negative 5x plus 5x is 0, negative 5y plus 3y is negative 2y, negative 5z plus 2z is negative 3z, and negative 2,850 plus 1,800 is negative 1,050. So now between equation 3 and what I labeled equation 4, there are 2 equations that have just y and z, and I can use them to solve. If I double equation 3, that'll give me a positive 2y to match the negative 2y, so that when I add them together, it will cancel the y terms out. So 2 times equation 3 is 2y minus 4z equals 0. Add it to my equation 4, the y's cancel. I get negative 7z equals negative 1,050. Divide by negative 7 and you get z equals 150, which means 150 preteens attended. Now I can use my z to plug in for y. This is actually the easiest equation to do it in. Y equals 2 times z. So y equals 2 times 150. 2 times 150 is 300, so that means 300 teens attended. And lastly, once I have the number of teens and preteens, I can just use one of my original equations to find the number of adults. X plus y plus z equals 570, the number of people at the concert. So substitute in your solutions. X equals unknown, y is 300, the number of teens, z is 150, the number of preteens. Now 300 plus 150 is 450, then you subtract that from 570, and you get the number of adults is 120. So your conclusion is 120 adults, 300 teens, and 150 preteens went to the concert. So this is 2 examples of system of equation types problems. I will do some matrix ones and then one inequality one as well.